Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner. In this video, let us understand together the second part of the coordinate geometry, which is the section formula. Section formula can be used to find the coordinates of point which divides a line segment in a given ratio. Let P be the point on the line segment AB. This is line segment AB and on which this is point P, and lies between AX1Y1 and BX2Y2. This is AX1Y1 and this is BX2Y2, such that AP upon PB equals M upon N, that is M as to N. Therefore, P is said to divide segment AB internally in the ratio M as to N. If point PXY divides segment AB, where A is x1y1 and B is x2y2, internally in the ratio M as to N, then the coordinates of P can be found by the section formula. The x-coordinate of point P will be mx2 plus nx1 upon m plus n, mx2 plus nx1 upon m plus n, and its y-coordinate will be my2 plus n by 1 upon m plus n, my2 plus n by 1 upon m plus n. Therefore, the coordinates of point P will be its x-coordinate mx2 plus nx1 upon m plus n and its y-coordinate my2 plus n by 1 upon m plus n. This is how we can find the coordinates of this point P with the help of coordinates of the endpoints of the segment A and B. In the first question, we will find the coordinates of the point which divides the line joining 1, minus 2 and 4, 7 internally in the ratio 1 as to 2. Let PXY be the required point. By section formula for internal division, we write x equals mx2 plus nx1 upon m plus n. We will substitute the values, so it will be 1 multiplied by 4 plus 2 multiplied by 1 divided by 1 plus 2. That gives us 2. Next, y-coordinate will be my2 plus n by 1 upon m plus n. By substituting the values, it will be 1 multiplied by 7 plus 2 multiplied by minus 2 divided by 1 plus 2. So it will be 7 minus 4, that is 3, divided by 3, which will be 1. So the coordinates of point P will be P2, 1. That is, this point P will be P 2, 1. We will understand the midpoint formula. If Pxy is the midpoint of segment AB, then AP upon PB will be 1 upon 1, that is 1:1. Therefore, by distance formula, we write the x coordinate of P as x equals 1x2 plus 1x1 upon 1 plus 1. That will be x1 plus x2 upon 2. And we write the y coordinate of P as y equals 1y2 plus 1y1 upon 1 plus 1. That will be y1 plus y2 upon 2. Therefore, we get the midpoint formula to find the coordinates of the midpoint of segment AB, which is Pxy. The x coordinate of point P will be x1 plus x2 upon 2, and the y coordinate of P will be y1 plus y2 upon 2. These are called midpoint formula. In the second question, we have to find the middle point of the line joining -3, -6 and 1, -2. The middle point of the line segment can be found by the midpoint formula, which is the x coordinate as x1 plus x2 by 2. That will be x1 plus x2 by 2, that will be -2 divided by 2, that is -1. So the x coordinate will be -1. Y coordinate is y1 plus y2 by 2, that will be -6 plus -2 by 2, that will be -8 by 2, that is -4. So the y coordinate will be -4. Therefore, the coordinates of the middle point will be -1, -4. Let us understand section formula for external division. When point Pxy, this point, lies on the extended part of segment AB, this is point A, this is point B, this is segment AB, and this part is the extended part of segment AB, and P lies on this extended part of segment AB and not between the points A and B. So please note this thing, such that AP upon PB, AP, which is M, upon PB, which is N. Here also, please note the change in directions. Therefore, minus sign is introduced here. Then P is set to divide AB, line segment AB, in the ratio m:n externally, and the section formula for external division is given as the x coordinate of P is mx2 minus nx1 upon m minus n. Please note the negative sign in the numerator and denominator, and the y coordinate of P is given as y equals my2 minus n by 1 upon m minus n. Here also, please note the negative sign in the numerator and denominator. In third question, we have to find the coordinates of the point which divides internally and externally the line joining a minus 1 2 and b 4 minus 5 in the ratio 2:3. Suppose pxy be the point number 1 which divides internally the line joining points a and b in the ratio 2:3. So its x coordinate will be x equals mx2 plus nx1 upon m plus n. That will be 8 minus 3 divided by 5, which will be 5 by 5, that is 1. And the y coordinate will be y equals my2 plus ny1 upon m plus n. That will be, this will be minus 10, this will be 6, so it will be minus 4 by 5. So the x coordinate will be 1 and y coordinate will be minus 4 by 3. So that is going to be the coordinates of point P when P divides the line joining AB internally in the ratio 2:3. Now next we will consider when P divides the line joining A and B externally in the ratio 2:3. So we have the x coordinate as mx2 minus nx1 upon m minus n. We know for external division we use negative sign in numerator and denominator. So it will be 4 2s are 8 and this will be plus 3 upon 2 minus 3 will be minus 1, so it will be minus 11. And the y coordinate will be my2 minus n by 1 upon m minus n. So it will be minus 10 minus 3 2s are 6, so and this will be 2 minus 3, that is minus 1, so it will be 16. So the coordinates of point P when it divides the segment AB externally will be minus 11, 16. In question 4, we have to find the ratio in which the point minus 3k divides. This is the point minus 3k which divides the line segment joining the points minus 5, minus 4 and minus 2, 3. So these are the points. Hence find the value of k. So we have to find the value of k. So we will start by supposing minus 3k divides this point, the segment in the ratio m:1. Okay, so x coordinate of minus 3k, which is this minus 3, will be minus 3 equals mx2 plus nx1 upon m plus 1. So that gives us cross multiplication minus 3m minus 3 equals, this is minus 2m and minus 5. So that gives us m equals 2. So now the ratio becomes 2:1. So by using 2:1 we will find the y coordinate, which is k. So we write k equals my2 plus n by 1 upon m plus n, that is 2 plus 1. So it gives us 2 3s are 6, 6 minus 4, that is 2, and this is 3, so 2/3. So we get k equals 2/3 So therefore the ratio will be 2:3 and the value of k will be 2/3. Fifth question is to find the ratio in which the line 2x plus 3y minus 30 equals 0 divides. So this is the line which divides the join of A 3 4 and B 7 8. And at what point? So we have to find this point. Suppose the line 2x plus 3y minus 30 equals 0, which is this line, divides AB at CXY. So let the point of intersection be CXY in the ratio k:1. Then x coordinate will be 7k plus 3 by k plus 1 and y coordinate will be 8k plus 4 by k plus 1. This is by the section formula for internal division. Next, CXY also lies on this line. Therefore, we can substitute for x and y as 2 times 7k plus 3 by k plus 1 for x plus 3 times for y. We can substitute 8k plus 4 upon k plus 1, which is this. It will be 14k plus 6 plus 24k plus 12 minus 30k minus 30 equals 0, which will be 8k minus 12. So k will be 12 by 8 or 3 by 2. So this is the value of k, and it also means that point C divides segment AB in the ratio 3:2. We have k equals 3 by 2. So the x coordinate of point C will be x equals 7k plus 3 upon k plus 1. We will substitute the value of k. It will be 7 3s are 21 and 3 2s are 6, and here it will be 3 plus 2 1s are 2, that is 5. So the x coordinate will be 27 by 5. Y coordinate will be 8 times 3 by 2, which is k, plus 4 divided by 3 by 2 plus 1. It will be 8 3s are 24, 4 2s are 8, 24 plus 8, and 3 plus 2, that is 5. So it will be 32 by 5. So the y coordinate is 32 by 5. Therefore, the point C will be 27 by 5 and 32 by 5. In question 6, we have to show that the points A minus 3 minus 1, B 1 3 and C minus 1 1 are collinear. Suppose C minus 1 1 divides AB in the ratio k:1. For x coordinate minus 1, this one, minus 1 equals k1 plus 1 minus 3 upon k plus 1, which will be minus 1 equals k minus 3. So that will be 2k equals 2. So that gives us k equals 1. For y coordinate 1, this one 1 equals k times 3 plus 1 times minus 1 upon k plus 1. It will be k plus 1 equals 3k minus 1. That will be 2k equals 2. So that gives us k equals 1. For both x and y coordinates, the value of k is 1. Therefore, the ratio becomes 1:1, which implies C is the midpoint of AB, which implies points A, B, C are collinear. In question 7, if the points A61, B82, C94 and D P3, this is A61, B82, C94 and D P3 are the vertices of the parallelogram taken in order, then we have to find the value of P, this one. We know that diagonals of a parallelogram bisect each other. Therefore, midpoint of diagonal AC equals midpoint of diagonal BD. So, the midpoint of these two diagonals is the same point, which is this one. So, we find the midpoint of diagonal AC, which will be 6 plus 9 by 2. That will be x coordinate, and y coordinate will be 1 plus 4 by 2, which is same as the midpoint of the diagonal BD, whose x coordinate will be 8 plus p by 2, and the y coordinate will be 2 plus 3 by 2. Now, by equating the x coordinates on both sides, we get 8 plus p by 2 equals 6 plus 9 by 2. These two gets cancelled, so we get p equals 15 minus 8, that is 7. So that is the value of P. In question 8, we have to find the points of trisection of the line segment joining A 2 minus 3 and B 4 minus 1. There will be two points of trisection. The first will divide segment AB in the ratio 1:2, and the second will divide segment AB in the ratio 2:1. Let the first point be PXY, which divides segment AB in the ratio 1:2. Therefore, its x coordinate will be 1 multiplied by 4 plus 2 multiplied by 2 upon 1 plus 2. So that will be 4 plus 4, that is 8 by 3. So the x coordinate will be 8 by 3. The y coordinate will be 1 multiplied by minus 1 plus 2 multiplied by minus 3 upon 1 plus 2. So this will be minus 1 minus 6, that is minus 7 by 3. So the y coordinate of P will be minus 7 by 3. So this will be the first point of trisection P 8 by 3 minus 7 by 3. So that will be the coordinates of point P, which divides segment AB in the ratio 1:2. The second point Q divides segment AB in the ratio 2:1. So therefore, its x coordinate will be 2 into 4 plus 1 into 2 upon 2 plus 1. So that will be 4 2s are 8, 8 plus 2, that is 10 by 3. So this is the x coordinate of Q, 10 by 3. Its y coordinate will be 2 into minus 1 plus 1 into minus 3 upon 1 plus 2. So that gives us minus 5 by 3. So the y coordinate of Q will be minus 5 by 3. So the second point Q, 10 by 3 minus 5 by 3, will be the point of trisection which divides segment AB in the ratio 2:1, and this point will be 10 by 3 minus 5 by 3. So these are the 2 points of trisection of segment AB. Let us understand the centroid formula. Centroid formula is useful in finding the coordinates of the centroid of a triangle. Now what is centroid? Centroid is the point of intersection of the 3 medians of a triangle. So let us find out the centroid of this triangle ABC. AD, BE and CF are the medians. AD, BE and CF, these are the 3 medians of triangle ABC. They intersect at a point. So this is the point where they meet. This point is called the centroid of triangle ABC. So this point is the centroid. If A x1 y1, B x2 y2 and C x3 y3 are the vertices of triangle ABC, then the coordinates of the centroid G x y are given as x coordinate x1 plus x2 plus x3 by 3, and the y coordinate is y1 plus y2 plus y3 by 3. In 9th question, it is given that the vertices of a triangle A 2:1, B 5:2 and C 3:4 find the coordinates of the centroid. Let Gxy be the centroid. By centroid formula, its x coordinate will be x1 plus x2 plus x3 upon 3, which will be 2 plus 5 plus 3 by 3, which gives us 10 by 3. So the x coordinate is 10 by 3. Its y coordinate will be y1 plus y2 plus y3 upon 3, which will be 1 plus 2 plus 4 upon 3, which will be 7 by 3. So the coordinates of the centroid xy will be 10 by 3, 7 by 3. So the coordinates of this centroid will be 10 by 3, 7 by 3. So this is about section formula in coordinate geometry. If you like this video, please click the like button, share this video with your friends. Do subscribe this channel to get more videos of this type. See you in the next video. Thank you.